Lesson 12, proving parallel lines. This is going to get used for proofs later on. Proofs are something that students struggle with, and so that's why I want you to get this introductory information in and that you understand it, because it's what you're going to end up using to answer questions that are going to be hard questions to answer later on. So even though we don't really look at investigations all that closely, we don't spend a lot of time in investigation 1 or whatever, but this information is one that you want to have down, which is postulate number 11. And it states this. It says, if two parallel lines are cut by a transversal, the corresponding angles formed are congruent. So let's address this. We know what parallel lines are, right? Let's say I've got two parallel lines that look like that. A transversal is a line that cuts through two parallel lines. Okay, so my blue lines are parallel. My red line is my transversal. Does that make sense so far? Okay, now they're talking about this. They said if two parallel lines. So we already know that these are parallel. Okay? If two parallel lines are cut by a transversal, then the corresponding angles formed are congruent. So the next thing that we have to understand are, what are corresponding angles? Right? Well, corresponding angles is an angle where I have an exterior angle and an interior angle on the same side of the transversal. Okay? Those aren't the only two corresponding angles, but that's what corresponding angles look like. Now you'll notice something, is that my little green angle here, this first one, notice that it's obtuse, which means I'm looking for an angle on the same side of the transversal that is also obtuse. Does that make sense? All right, so we can see that not only are they congruent, but at least they look congruent. I could tell that, right? All right, so those are corresponding angles. So if I have two parallel lines that are cut by a transversal, then I know all of their corresponding angles are congruent. Other corresponding angles would be this angle and this angle. Okay, those are corresponding angles. They're on the same side of the transversal. One's interior, one's exterior. You follow me so far? Okay. Let's see, which is going to bring me to my next point, is that there is a converse of postulate 11. Okay. Converse means, if you remember, I don't remember if have we talked about conditional statements in here? That if then? Okay. So a conditional statement is if hypothesis then conclusion, right? And we should have talked about a converse statement. Converse is where I take the conclusion and I move it to the hypothesis. I take the hypothesis and move it to the conclusion, right? Does this ring a bell? Okay. So a converse of this statement, if two parallel lines are cut by a transversal, then, that should be a then, not a the, well, or then the corresponding angles formed are congruent. So if I was going to write a converse statement, the converse statement here would be, if the corresponding angles formed are congruent, then the two parallel lines cut by the transversal are parallel. So I can flip it the other way around and say, well, if my corresponding angles are the same degree measure, then I know that my two blue lines here cut by this transversal are parallel to each other. Okay? So a lot of these postulates, a lot of these conditional statements have a converse that's also true. Okay? So if I didn't know those lines were parallel, but I knew that my corresponding angles were congruent, I would know that they were parallel. If I know that they're parallel, then I know that my corresponding angles are congruent. All right. This next slide, this does not exist in your book, but this may be one of the important slides that you get your head wrapped around. All right, what are corresponding angles? Well, we've already talked about that. Angle 1 and angle 5 are corresponding. I've got a list over here, 1 and 5, 2 and 6, 3 and 7, 4 and 8, okay, are corresponding angles. If you go back and you look at slides, if you go back and look at notes, stuff that I've sent you, this may be one of the more important slides that you go back and you reference. Okay? All right, then we have what we're going to cover up here later on in some of our future postulates are alternate interior angles. Alternate interior. Interior means between the parallel lines. Okay? Interior. Okay? interior. Okay? We're also going to have exterior. These four are exterior angles. Okay, do we understand the difference between interior and exterior? All right. All right, so alternate interior angles means 4 and 5, 3 and 6. Okay, alternate interior. Alternate means opposite sides of the transversal. Okay, so when you see the word alternate, you ought to be thinking opposite sides of the transversal, not opposite sides of a parallel line. Okay? I know I'm repeating this stuff over and over again. Do we understand it? Can I get a head wobbling up and down? This makes sense. Hopefully. Okay? All right. So we've got alternate interior, like 4 and 5, 3 and 6. We have alternate exterior, like 2 and 7, okay, or 1 and 8. Okay? So, and then we have same side interior, which would be 4 and 6, 3 and 5. Now, we're going to talk about those angles and what has to happen with them to prove what it is that we need to prove. Okay? The next one up on the list is the converse of the corresponding angles postulate. If this will let me get rid of all that craziness. There we go. All right, this is one that we've already talked about. This was one from the previous page. The converse of postulate 11 is the converse of the corresponding angles postulate. If two lines cut by a transversal are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. Because measure angle 1 is congruent to measure angle 2, then I know that these two lines right here are parallel to each other. Postulate 11 says if these two lines are parallel, then angle 1 is congruent to angle 2. Okay? Works both ways. Next one on the list, Theorem 12-1. Okay? Alternate interior angles. This tells me that if I have if two lines are cut by a transversal, okay, here's two lines cut by a transversal P, then their alternate interior angles are congruent, then the two lines are parallel. Okay, the converse is also true. If the alternate interior angles are congruent, then the two lines are parallel. If the two lines are parallel, then the alternate interior angles are congruent. Okay? Yes? Got it? Great. Okay? Converse of the alternate exterior angles. Okay, if two lines are cut by a transversal and the alternate exterior angles are congruent, then the lines are parallel. The opposite of that is true also. If I have two parallel lines cut by a transversal, then the alternate exterior angles are congruent. Okay? So there's really just some terms that you've got to know. You need to know what parallel lines are. You need to know what a transversal is. You need to know what corresponding angles are and how to find them. You need to know what alternate means, right? You need to know what interior means. You need to know what exterior means, okay? And how those terms are used. Okay, converse of the same side interior angles theorem. This is one of the last ones, and it's not like the others. Okay, same side interior angles is a separate thing. With the other ones, with corresponding, with alternate interior, with alternate exterior, all of them were based upon those angles being congruent, correct? Same side interior is different. Notice that angle 1 and angle 2 aren't necessarily equal to each other, right? Now, granted, in there it may look kind of like it, but they won't always be. Okay, what we're looking here is to see if they're supplementary. What does the term supplementary mean? Remember, this was like a day 2 question. What does supplementary mean? Measures that angle measures that add up to equal 180 degrees. Just by matter of review, what does complementary mean? Jose, do you remember what complementary means? Two angles that add up to be 90 degrees. Okay, good. All right, so if angle 1 plus angle 2 equals 180 degrees, then I know that these two lines cut by that transversal are parallel. Okay? if those two lines are parallel, then I know that measure angle 1 plus measure angle 2 will equal 180 degrees. All right, that's the end of that. Okay? This, I think, is one of the more important things that you can know and understand is this slide right here. Okay? Are we on board? All right, let's see if we can pull up and answer some questions. Let's see. All right. Look at this. This says measure angle 1 is congruent to measure angle 2. Prove that line L is parallel to line M. Well, what postulate or what is the statement there that's going to tell me that those lines are parallel to each other? Go back and look in your notes. What is angle 1 to angle 2? What are they to each other? Look in the list. Yeah, I'm asking you. What are they, Jordan? Can you tell me what 1 and 2 are to each other? Are they alternate interior, alternate exterior, corresponding, same side interior? What are they? Yeah, this tells me right here that they're congruent, right? But what are they? I'm giving you, yeah, I know that you've got the answer. All right, are they corresponding, alternate interior, alternate exterior, or same side interior? Those, you've got 4 choices. Corresponding, exactly. All right, and tell me about corresponding angles. If they are congruent, what does that mean? Okay. Okay. That's exactly it. The definition is correct. Okay? All right, so let's look at our options in here. Which one tells me that angle 1 and angle 2 are corresponding angles? Is there more than one? B. Okay. Yeah, B. B says that they're corresponding angles, right? What's the difference between B and C, though? They both say corresponding angles. Can they both be correct? The postulate that you just read was exactly right. Jordan, can you tell me what it was? Was it the corresponding angles postulate, or was it the converse of the corresponding angles postulate? Which one was it? There was nothing. There's no word in front of it. Let me see it. So you see that word right here is the difference between getting this question right and getting it wrong. Okay? All right, it is the converse. Converse is when when I have congruent angles. When the angles are congruent and I'm trying to prove that the lines are parallel, that's the converse. The corresponding angles postulate says that if two lines are parallel, then their corresponding angles are congruent. Does that make sense? So the original postulate always begins with the lines are parallel. The converse is always these angles are congruent. Therefore, they are parallel. Okay? All right, so that's that question. All right, let's look at this. All right, this is going to take it, and now we're doing some algebra with it. All right, what is angle 1 to angle 2, Chandler? What are they to each other? Remember, there's 4 options. What are the 4 options? Corresponding. You need help with another one? Okay, somebody give him another one. There's corresponding angles. What else? Alternate interior, that's 2. Same side interior. One more. Alternate exterior. Okay. So, Chandler, these 2 angles, are they corresponding? Okay? Are they alternate of each other? Okay, they're on opposite sides of the transversal. Are they interior or exterior? They're interior. So we would say that these are alternate interior angles, right? All right, so we know what they are. Okay, now let's look at this. We want to prove that these two lines are parallel. We have to check something first, because in order for those two lines to be parallel, according to the converse of the alternate interior angles theorem, they would have to be congruent. Is that correct? Yes or no? Yes. So for them to be congruent, if measure angle 1 is 3x plus 30, and this is 5x minus 10, all right, so we got 5x minus 10, we've got 3x plus 30. What do I need to do with those two angles? If I'm going to prove that these lines are parallel, what do they have to be? They have to be equal to each other. So what am I going to do? Set them equal. 3x plus 30 equals 5x minus 10. Okay, now go about solving for x. Notice what do they say, though? Look at the rest of the statement. X equals 20, so what should I do next, Jose? Plug it in. So 3 times 20 plus 30. Does that equal 5 times 20 minus 10? Okay, well, what's 3 times 20? What's 60 plus 30? All right, so 90. Okay, what's 5 times 20? What's 100 minus 10? 90. So both these things equal 90. Granted, our picture's not to scale because those are clearly not 90 degrees. They're clearly obtuse. But notice it says by substitution. Okay. All right, so let's look down through here. We should be getting 90 to 90, right? We seem to get that with the first one by substitution. Let's see, we see by the substitution property of equality, measure angle 1 equals measure angle 2 equals 90 degrees. By the converse of the alternate interior angles theorem, L is parallel to M. Does all that seem to be accurate and correct? Yeah. Should be. Okay? Because we definitely want the converse because we are proving that the lines are parallel. We don't know that the lines are parallel, so we're going to use the converse. Okay? Let's see. Let's see if there's anything wrong. We see 90, 90, since measuring angle 1 or angle 2 are alternate interior angles. Okay, measuring angle 1 equals 2 equals. Notice this says 180. That's where our mistake is here. Okay. A ends up being our answer. Let's see if we can scroll down and answer why any of the others are wrong. Okay, notice that C says same side interior angles and equals 180. Okay, we don't want that. They're not same side interior. D also says same side interior. That's how we wind up with A as our answer. So sometimes in a multiple choice question where it looks like there's a lot of information being received there, in the first one looks like the right answer, I think it's a good practice to go through, okay, this one looks right, but why are the others wrong? Okay, because I might be wrong. Okay? All right. Let's see if there's anything else in here that can be a help to us. All right, let's do at least one more. Okay. Let's see. In a swimming pool, we've got two lanes. They're represented by L and M. If a string of flags crosses, that's my transversal here. Across the represented by transversal T and X equals 10. Show that the lanes are parallel. So just kind of like that last question we looked at, what are we going to do with the X's in this? Set them equal. No, not set them equal yet. What am I doing with the X? Substitution, right? I'm substituting in 10 for X, right? But then I want to see if these things are equal. What's 3 times 10? 30. 30 plus 4 is? 34. Okay, we got 34 here. Okay. What's 4 times 10? 40. Minus 6? 34. All right. 34, 34. All right, what are those two angles to each other? No, more specific. Go back to my 4 categories. Alternate interior. So they're alternate interior. Am I going to use the alternate interior angles theorem, or am I going to use the converse of the alternate interior angles theorem? Which one? The converse. Why the converse and not just the alternate interior angles theorem? Because I'm trying to prove that the lines are parallel. Okay, again, the alternate interior angles theorem says these two lines are parallel, therefore their alternate interior angles are congruent. The converse says if these angles are congruent, then these lines are parallel. Okay? We need to get that down, otherwise we're going to continue to get tripped up and get, we're down to a 50-50. I don't want you to be down to a 50-50. I want you to know what the right answer is. Okay? Notice that A is wrong. Can you tell me why A is wrong? Okay. Right, because right there needs to have the word what? Converse. How many of you understand? Are you sure you understand? You understand when to use converse and when not to use it? Yes? Yeah, because you're not raising your hand and I don't see confidence on your face. Right? I guarantee you coach can look at you and tell you if you see who's got it and who doesn't have it. Do you have it? No. Okay. Let's hit it again. All right. The alternate interior angles theorem says, I know that these two lines are parallel. All right. Therefore, I know that this is equal to that. Okay? The converse, which is what we have here. If it asks me to prove that anytime it says prove these lines are parallel, we're going to use converse. Anytime it says prove these lines are parallel, converse of. Okay, does that help? So basically what that would be is if I have this right here, right, I'm starting with these. Converse says I start with this. Okay? I start with the angles. Okay? The regular normal one says I'm starting with parallel lines. All right. So let's see. Then the correct answer looks like it should be B. The angles are alternate interior angles and they are congruent, so the lanes are parallel by the converse of the alternate interior angles theorem. Okay? All right. Hopefully we got that down now. Let's see. This question, I know this question has showed up on tests before, and people miss it all year. I say all year because sometimes, like if I see there's a question that you're struggling with, I'll continue to put it on test after test after test until we get it. Okay? All right, use the diagram for the following problems. Which pair of angles, if congruent, proves that lines A and B are parallel? Okay? Let's start with 6 and 5. Remember, we only have four sets, right? Or actually less than that. We only have 3 things that, if they are congruent, prove that 2 lines are parallel, right? What are they? Remember that there's 4, but only 3 of them deal with congruency, right? The 4th one is same side interior, and that's supplementary. So corresponding angles. Okay, we need to be able to identify those 3 things every time. All right, so let's look. Are 6 and 5, angle 6 and angle 5, are they any of those 3 things? Are angle 6 and 5, this angle here and this angle here, are they corresponding? I got them highlighted. They're 6 and 5. Are they anything? No, they're nothing on this list. They're not corresponding, they're not alternate interior, they're not alternate exterior. Okay? The next one on the list, 4 and 2. Here's 4, here's 2. Are they anything on that list? What are they? No, they're not. Look, is 2 exterior? 2 is not exterior. Okay, so listen, here's the thing, is I can't prove that these two lines are parallel unless both of them are touching a separate line. Okay? So angles 4 and 2, they only touch line A. None of them has anything to do with line B. So could they prove that line B is parallel to line A if neither one of them has anything to do with line B? No. Okay, so that can't be it. Okay, it can't be 6 and 5 because neither of those touch line A. It can't be 4 and 2 because none of those touch line B. Let's look at 6 and 1. Look at 6 and 1. Are they on my list of 3 possibilities? 6 and 1. What are they then? Are they corresponding? They are. No, they're not. Okay. Can you pick out 2 corresponding angles for me? Just any 2 corresponding angles. What are they? Give me 2 corresponding angles. Don't even have to be one of the ones that they're listing here in the answer set. Identify corresponding angles. Yeah. You got your notes? Okay. Go back to that second slide in the notes. No, 8 and 5 are not corresponding. Jose, can you help him out? 4 and 8. Yep, 4 and 8. Remember, okay, this is why I say things. And I don't just say this to throw like words out into the air. All right? Corresponding angles are going to be on the same side. One will be exterior, and one will be interior. Okay? So looking at 6 and 1, what do you notice? 6 is what? Is it interior or exterior? What's that? Interior is inside the parallel lines. Inside. Okay? Do you understand inside? Is between the 2 parallel lines. Exterior is outside the parallel lines. Outside. Okay? So, 6 and 1. Are either of them interior? No. So can 6 and 1 be corresponding? No. All right? They're not. Are either of them alternate to each other? What does the term alternate mean? Listen, I'm not just trying to pick on you, but if you don't understand it, then you won't be successful. Okay? So I'm just trying to help you be successful. What does the term alternate mean? What does alternate mean? Other. In this case, other side. On the opposite side of. Okay? But in this sense, opposite side of what? Because if we don't know what we're supposed to be alternate of, we won't be able to figure this out. On the opposite side of what? One line. Okay? Let me erase some of this. Alternate means opposite sides of the transversal. Okay? So 1 is alternate to 7. Right? They're on opposite sides of that red line. The 1 and 7 are what we call alternate exterior. They're on opposite sides of the red line, and they're both exterior of the parallel lines. Okay, which would fit that right there. Okay, so would 4 and 6. Those are alternate exterior angles. Okay, alternate interior are 2 and 8, or 3 and 5 are alternate interior. Okay, I'm going to hammer this home. Because like I said, this might be one of the more important lessons that you guys get, that you have to get. You can't skip this and say, well, I don't really need to understand this. I'll just understand the next lesson. This will come back. Okay? So, are 6 and 1 anywhere on this list? No. Okay? So, the answer has to be 5 and 1. The question is, what are 5 and 1 to each other? Marcos, what are 5 and 1 to each other? They're alternate interior. 5 and 1 are? Here's 5, here's 1. What are they? 5 and 1. Corresponding angles, because they're not alternate, right? Okay, so there's only one thing left on the list for them to be is corresponding. 1 is exterior, 5 is interior, right? So that's the part of it that makes sense. And they're touching, 1 is touching line A, 1 is touching line B. You can look and see that's obtuse, right? They look like they're equal to each other. That helps. Okay? So 1 and 5. You got to get this down. Okay? All right. Let's stop there.